Let's move on to some average value problems now. And for average value, you're simply following a very basic formula. So average value is equal to 1 over b minus a. And you're going to multiply that with the integral from a to b of f of x dx. And basically, you just apply this to the function over the given domain. So in this very first problem, you're given a parabola y equals to 9 minus x squared. So this is your function f of x. And this is your given domain from 0 to 3. So these are your values of a and b. So a is always your first number. So a is 0 and b takes on the value of 3. Okay, so let's go ahead and plug in the average. Let's go ahead and use the average value formula now. So 1 over b minus a. So b has a value of 3. So it's going to be 1 over 3 minus 0. And then you're multiplying that with the integral from a to b. So 0 to 3. And your function is 9 minus x squared times dx. Okay, so that's the equation that you're solving. It's really not too hard. We've done a fair bit of these back in chapter number 6. So let's go ahead and evaluate this now. 1 over 3 minus 0. So this part right here in green, that's simply going to be 1/3. And then if I take a look at 9 minus x squared, the antiderivative of that is going to be 9x minus x cubed divided by 3. And then I can close that bracket, and I'm going from 0 to 3 for that particular integral. Okay, so once we've plugged in, once we've taken the antiderivative, basically we're just using the fundamental theorem of calculus now, and I'm just going to move the work up to here. So the 1/3 will remain. And let's go ahead and evaluate the upper limit first. So the 3 would go in for all the x's. So let me just create another bracket here. So this would be I'll say 9 times 3, I guess. 9 times 3 minus 3 to the power 3 divided by 3. And let's put that all in the bracket. And then the next sign is going to be a minus sign. And then the good news here is we have a 0 here. So when 0 goes into that essentially just goes to 0. So be bracket 0, close the bracket, and then close the bigger bracket here. And that's using the fundamental theorem of calculus there. And after that, we just need to calculate the final answer here. So the 1/3 would go right there. The red bracket there, 9 times 3 is going to be 27 minus, well, 3 to the power 3 is 27. 27 divided by 3 is going to be 9. So 27 minus 9, and minus 0 is going to be 0. So basically now your final answer should be 1/3 of 27 minus 9. And if you do the math here, this is going to be 6. So the average value here is 6. So basically what that really means is the average value of 6. If you take a look at this interval from 0 to 3, you have all these different heights. You have infinitely many different heights. Some heights are obviously bigger than the smaller ones. But there's quite a bit of different y-value heights represented by the orange color. And if you take the average of all those orange vertical lines, the average of all that is going to be a value of 6. So your average height takes on a value of 6. So that's what the 6 value means here. It just takes the average of all those orange heights, averages it out, and the average height is 6. So obviously some heights are bigger than 6 and some heights are lower than 6, but the average is going to be 6. Okay, let's move on to letter B now. For letter B, I want to find all the x values on the interval where the function attains its average value. Okay, well, the interval is going to be from 0 to 3. And I want to find all the x values such that the x values have a y value of 6. Now, if I follow this green line right across, I think there's only one x value where it does match up. So I need to find this x value right there. So I want to find all the x values that have the average height, which is 6. So all you're really doing is you're taking your original function, which is 9 minus x squared. Let me just erase all this. Okay, so let's just take our original function, which is 9 minus x squared. And basically, we're going to find out when it takes on the y value of 6. So we just make this equal to 6, and then we just solve that equation. I can interchange those two pieces, so I get x squared equals to 9 minus 6. 9 minus 6 is going to be 3. 3 equals to x squared. And then I can take the square root of both sides. And although the square root of 3 is really plus or minus 3, we just need to focus on the positive value of 3 because our interval, remember our interval here is going from 0 to 3. So that means root 3 is definitely in that interval. Okay, so that means root 3 is going to be this guy right here. This is going to be root 3, and root 3 is about 1.7 something. So when x has a value, when x is root 3, then it has an average height of 6. And that's all it is for that particular question. And the rest of the questions in this section are very similar. You find the average value, and then you find the x values where the function actually has its average value. Okay, so let's move on to the next one here. Let's move on to this question here. Find the average value for this function. Now for this function here, I have the square root of 16 minus x squared. And this function is simply just, it's basically a circle right here. And I'll label this f of x. So f of x represents this entire area. So if I want to find the average value, I can write down average value. Average value equals to 1 over b minus a. Now a is negative 4 and b is 4. So if I do b minus a, it's going to be 4 plus 4. And then basically I'm going to go from the integral from a to b, which is from negative 4 to 4. And for now, I will write down the expression of root 16 minus x squared and then times dx. Okay, now for this particular problem, I'm not going to find the antiderivative of this expression right here in the green box, but ask yourself, the green box, how is that related to the picture there? Because essentially we're trying to find the area between negative 4 and 4. Okay, so if we have that idea in mind, if you think about this region here, this is really, it's really a half a circle, right? So the equation of y equals to the square root of 16 minus x squared, it really represents half the area of a full circle. And we know the area of a full circle is pi r squared. So pi r squared is the area of a full circle, and if I want half of it, I just divide by 2. And then ask yourself, what is the radius from here to here? Well, this radius is simply going to be 4. So this will be pi times 4 squared divided by 2. Well, 4 squared is going to be 16. 16 divided by 2 is 8, so this will be 8 pi. So that works out really nice because I can just speed up my calculations now. If I look at this blue box here, 1 over 4 plus 4, that's going to be 1 over 8. And this entire green section right here, that's just the area from negative 4 to 4, and we just calculated that area is going to be 8 pi. So I can just times this by 8 pi. The pi's just cancel off, and my average value is just pi in this case. Okay, so let's just erase all this. And let's erase our original diagram here. So my average value is pi. So what that means is pi is about, what, 3.14? So if I look at my original graph, 3.14 is probably around here. So this is my average value right there, pi. And then for part 2 is just asking for find all the x values where the original function has a height of pi. So there's probably going to be 2. So the two heights are the two x values are these orange question marks right here. So the next part of the question is I need to find the x values where the y heights are pi. Okay, let's erase this. And just like the previous question from question number 1, we just take our original function, which is 16 minus x squared, and we just make that equal to the average value found in part 1, which was pi. And then we just solve for x. All right, so I can square both sides. If I do that, I get 16 minus x squared equals to pi squared. And then what I can do now is I can take this negative x squared and this pi squared, interchange them. So I get 16 minus pi squared equals to x squared. And then finally, I can take the square root of both sides. And then I need a plus and minus for this particular question because my domain goes from negative 4 to 4. So this is going to be negative the square root of 16 minus pi squared, and this one over here will be 16 minus pi squared, positive. And that's it for that particular question. We just found the average value, which was pi, and then we find the corresponding x values that give us the y values, the y value of pi. Okay, let's move on to the next one, question number 4. All right, so once again, I got to find the average value for part A. So average value, the formula is 1 over b minus a, and I would plug in my a and my b right away. So 1 over b minus a would be 1 over, and then my b value is 1, so there's a 1 there. Then I have a minus sign, but there's a minus sign over here, so minus and minus will give me plus, and then I need a 1 there. And then I need my integral from -1 to 1, and my function this time is going to be 20 over x squared plus 1, and then I need my dx at the very end to finish it off. So that's how you can plug in the numbers and the function into your formula there. And then let's just continue breaking this down. 1 over 1 plus 1 is going to be 1/2, so 1 over 2. And one more thing that you might want to do is there's a 20 here. Let's just bring that to the outside. So I can put my 20 there, and then I can have my integral sign from -1 to 1 of 1 over x squared plus 1 dx. And then I have 20 divided by 2, which is going to be 10, so 10. And then this part right here, that part in yellow there, that's actually one of the inverse trig functions. So the antiderivative of 1 over x squared plus 1, that's going to be the inverse of tan. So tan inverse x, and then I'll put that in a bracket, and I'm going from -1 to 1. Okay, and then from there, let's go ahead and plug in our upper bound. So if I do that, I get 10 times 10 inverse of 1 minus, and then we plug in our lower bound, so that's going to be tan inverse of -1, and then I can close the bracket there. There's some other ways you can definitely approach this antiderivative because it looks like to be an even function, but feel free to just kind of plug in those values and you can probably still figure it out. I will just do this a long way instead of using the even properties portion to solve the problem. Now, if you're trying to evaluate the inverse of tan here, think about the tan function from pre-calculus 12. I mean, here's your tan function, y equals to tan x, and you should know that one of the very good points, the height of 1 takes on an x value of pi over, I think it was pi over 4. And over here, when I have negative pi over 4, this has a height of -1. So this is very useful because if I'm looking at the inverse of tan of 1, I mean, if I look at this y value here, the x value that gives me a y value 1 is pi over 4. So if I go ahead and just plug that in, the inverse of tan of 1 is going to be pi over 4 based on my graph. And then need a minus sign. And then if I take a look at this negative value here, if that's my y value, what x value gives me a y value of -1? Well, if I follow it, it's going to be negative pi over 4. So this will be negative pi over 4. So you can use your graphs to find the exact values. I think that works out quite well. So pi over 4 plus pi over 4. And pi over 4 plus pi over 4 is 2 pi over 4. And then 10 times 2 is 20, and 20 divided by 4 is going to be 5. So this will be a 5 pi for my average value. Okay, so there's my average value. And if I go back to my original graph here, let me just kind of erase all this work here. I don't think I need that anymore. I know that 5 pi is probably going to be somewhere around here. So this is going to be about 5 pi. So just like some of the previous questions, I guess we'll have two x values. And that's the next part for part B. We need to find the x values that have a height of 5 pi. So all you're doing is you're taking your original function, which is 20 over x squared plus 1. And you're just making that equal to 5 pi. One thing that you can do right away is you can take your denominator and the 5 pi and you can just interchange those two pieces. So when I interchange those two pieces, I get 20 over 5 pi equals to x squared plus 1. After that, I can take my plus 1 and then I can move that to the other side. So if I do that, I get 20 over 5 pi minus 1 equals to x squared. And then after that, I can take the square root of both sides. And then I need a plus or minus there. So this right here, these are your following x values that do work for that particular problem there. And I guess over here, this question mark should be the minus the square root of 20 over 5 pi minus 1. And this one over here should be the positive of 20 over 5 pi minus 1. So something like that, yeah. And if you want to simplify this more, I mean, 20 divided by 5 is 4, so it'll be 4 over pi, but I'm a little bit lazy right now, and I think most students will probably get the general idea here. Okay, so we move on to question 5 now.